All right, as we take a look at example 2, I strongly encourage you to try this one on your own first and just see how you do, see how far you can get, and then come back and walk through it with me. Or if you're not feeling quite confident enough yet, then please go ahead and follow along as I go. Without reading all of the information there, because you can do that on your own. So first thing, verify that the sampling distribution is normally distributed. Well, we happen to know that we have 32 death row inmates that have been selected, and so we've met the criteria that the sample size be greater than or equal to 30. So that's how we know the sampling distribution is normally distributed. Write out the null and alternative hypothesis. So getting ready to do that. Based on 2002 data, the average age of someone on death row was 40.7 years old. And then we want to figure out if there is enough evidence to show the average age of death row inmates has changed. Now again, it isn't indicating one way or another. So you have to think going into this. I know we've got a researcher that has this data now, but going in, this person would have no idea whether it's gone up or down. She just thinks, I don't think it's 40.7 years anymore. Let me see if it's different now. So whenever that's the case, we use the not equal to, and in this case, the 40.7 years. All right, the sample mean and the standard deviation, again, should not be hard to find. 38.9 years and standard deviation of 9.6 years. Find the test statistics. So again, this is now going into your calculator and entering all of the necessary information to make that happen. So starting with stat tests and your t-test, now we're putting in stats, remember. So once you highlight stats, go ahead and hit enter, and then it'll give you the option to enter your null hypothesis of 40.7, our mean of 38.9, the standard deviation of 9.6, our n of 32, and then we want to test that mu is not equal to the null hypothesis, so that first one there, and then go ahead and go on down to calculate. You should find that your test statistic is negative 1.0607. The p-value, again, pulling that from your calculator, is going to be 0.2970. Okay, now decide whether or not to reject the null hypothesis based on the level of significance. So we were given a 5% level of significance. And again, this is a two-sided test. So when it comes to our area, we've got that 5% on both ends. So this kind of summarizes what's there. Now, we were below the mean, and so we know in actuality our value falls on the left edge of the curve. But when we're looking at that p-value of 0.2970, that is way the heck out here. That's nowhere near being in that bottom 5%. So we are not going to reject the null hypothesis. Okay, and so our conclusion would be we do not have enough evidence to support the claim that the average age of inmates on death row has changed. Okay, now if we take a look at the 10% level of significance, notice that our p-value of 0.2970 is also not going to even make it into that most extreme 10%. It is still way above that. And so the conclusion is the same as in part G. right? Because again, even if we move this marker out here to 10% and 10%, that 0.2970 still falls well in the middle section, not to those outer tails. All right, we've got one last example in this section. And before you go through the example, again, I would strongly encourage you to try it on your own and see how you do. Then play the video, or even just fast forward to the very end of the next video and see if your numbers match up with mine.